Welcome back once again. It's been a while. Schedule has been tight. Okay. Now, this is one of the recent IGCSE additional math May June 2020 question. I find that it's a bit interesting to work with. So here I'm going to present the solutions to this. Right. Um, Welcome once again. My name is Mr. Chai. If you are interested with what you're looking at, uh, don't forget do subscribe and then press the notification bell so that you can receive the next video that I will be uploading in the future. Okay, now you can see that this is one of the IGCSE additional math question. You can look at the title below, and then the topics is on integration. All right, let's get started. Right now, before we get started, the main objective for this question is um, we are given two functions here, fx and gx. One is a linear equation, the other one is a rational function. We need to evaluate the area bounded by the curve, the blue curve, and then bounded by the straight line equation, and then at the same time bounded by the x-axis and the vertical line x equal to 2. Right. So what we are looking at here is we are looking at the area under the straight line, and at the same time we are also going to find this area here. So we are looking at the total area between this region and this region here. All right, since we are clear of the objective, let's get started. Okay. Now, how are we going to approach these questions? Typically, is quite direct. I'm going to apply divide and conquer strategy. Here, we're going to work out or evaluate the area under this straight line. Basically, if you look at it from the geometry perspective, we are looking at area for triangle. Let me label this. This is area of triangle. Let me label this as A, B, and O here, since this is the origin. Okay, so all you need to do is work out the area for this triangle AOB. Since this triangle is right angled triangle. Okay. Now to do this, first of all, we have to figure out the y-interception and then the x-interception here. So the x and y intersects, we can obtain that directly from this equation here, x plus 1.2, right? You can see that. From there, we can identify that the y-intercept is given as 1.2 here, and then whereas the x-intercept is given by negative 1.2. Right. So I hope that you guys are clear how to work out the x intercept and then a y intercept here. Right. So just to recap, to work out the x and y intercepts, the steps are here. Just to walk through one more time, we will let for x-intercept. So for x-intercept, we will let the y equal to 0. And then in this case, the y that I'm referring to is the function gx, which is given as x plus 1.2. So by letting your y equal to 0, that would yield 1x plus 1.2 equals 0. That would produce x equal to negative 1.2. That's how we get this x-intercept. Now to get the y-intercept, we will let x equal to 0 in this case. So once we let x equal to 0, our y, which is given by gx function here, is actually equal to 1.2. So that is our y-intercept. So now we are ready to obtain the area for triangle. So area, okay, let's work this out. Area of triangle AOB in this case is given as, I'll label this as A1, it's easier to refer later on. So the width is 1.2 and then the height is 1.2. Okay. So that will be like, in this case you get 1.44, so 0.72 unit square. Right, now that's the area for the triangle AOB. Now next we are going to obtain the area under the curve from 0 to 2 here. Right. Okay, so I hope you guys are okay with getting the area for triangle. That shouldn't be a problem. All right, now just as a reference, I will write my result here just to keep it as a reference. So the area for triangle is given as 0.72 unit square here. Okay, let's look at how do we work out the area under the curve from 0 to 2. Now to do that, we have to apply integration rule to fx by using a lower boundary of 0 and then an upper boundary of 2. Okay, so basically area, okay, let me write this down. Area under the curve. In this case, I'm interested to get the area under the curve from x equal to 0 to x equal to 2 for this particular function, rational function, 3x squared plus 13x plus 10 dx. Now, at the first glance, this function is pretty intense, and then packed with flavor, though. Okay, hopefully it's good for digestion. Okay, now in order to work this out, we are going to look at the functions and then see how we are going to simplify the integration so that we can work with the integration more easily. Just by looking at this whole function itself is quite difficult to integrate it directly. Right. So one way we can do this would be we can break it down using partial fraction. This one method. We can actually break it down using partial fraction. Okay, let's give that a try. So the method that we are using is partial fraction method. Right. Now to do that, we will let 5x plus 12, 3x squared plus 13x plus 10. Now, first of all, we have to check whether we can factorize the denominator. In this case, from experience itself, we notice that this is quite easy to factorize, I would say. All right, so that is basically 3x plus 10 and then x plus 1 there. Okay, just let me quickly check that to see whether I got it right. Okay, so there you have it. That is the factorization of this function fx. All right, now next, the partial fraction. So we will let this 5x plus 12 equal to its partial fractions form. All right. And then from here, we are going to solve for a and b so that we can get its partial fractions format. One way we can do this would be okay. That will be equal to 5x plus 2 by comparison. Right? Now the easiest way to obtain a and b is by um, is to use substitution. So we can substitute x equal to -1 in this case. So once you substitute x equal to -1, we indirectly get rid of the variable a itself. Okay, so in this case we only have b, -1 here, so we have a 7, and then in this case there is -1 also, so that is a 7. That would yield a b equal to a 1, right? Now the same thing, next we can choose another value where we can substitute into this equation here, equation number 1. Right, so we can substitute, usually for me I prefer to use a 0, it's easier. So from here we have a, if we substitute 0 into equation number 1, we have a, and then 3x becomes 0, so we have 10. But anyway, we knew that b is 1, so that must be a 10. X is 0 on the right hand side, only left with 12. Therefore, a would be a 2. And then from here, we conclude that the partial fraction for 5x plus 12 over 3x plus 10 x plus 1 is equal to 2 over 3x plus 10 plus 1 over x plus 1. Of course, you can do a very quick check to see whether we obtain the rational functions here. Okay, just let me quickly check through that in case I make any mistake. Right. So 2x plus 2 there, so I have 5x plus 12. Okay, so after checking, yes, I'm quite happy with the result. Now we can check on this. This is the partial fraction. So I'm going to copy down this result at the side here, so that way we can continue on with the integration. So from here, we found out that 5x plus 12, 3x plus 10, okay, that is x plus 1 is equal to 2, 3x plus 10 plus 1 over x plus 1 there. Now that is our partial fraction. I'm going to take this out at this moment. Okay. Now we're going to continue on with this integration. So by integrating this rational function, we are saying that we can actually integrate this instead. Okay, so we can use a divide and conquer strategy to integrate this rational function by using its partial fractions format. All right. Now, just to recap, just a note here. I'll just write it down and then I'm going to erase that off. Just a piece of note here. We knew that integrating 1 over x would yield ln x, and then therefore integrating 1 over x plus 1 would yield ln x plus 1 here. That is the result. Here I did not put c here because our focus is mainly on the integration of the function itself. And then the toughest part would be integrating this part here. 2, 3x plus 10. So we have to be a bit careful with this. The best way to do this would be to, maybe from my perspective, I prefer to bring this number out here. So therefore I will have 1 over x plus 10 over 3 dx. Okay, so from here it's easy to see that this format look quite similar to this one here. So from the past integration result, we can conclude that this is the same as ln x plus 10 over 3. Okay, so using this result, result number 1 and the result number A and B, we can continue our work from step number 2 here. Alright, I hope that's okay. Okay, so take a moment to just capture this result. We're going to use it in a while. Alright, so if you're ready, I'm going to clear this off. So we have, from here, we have, after integrating, we have 2 over 3 ln x plus 10 over 3. Because this is definite integration, so we will substitute this value in, and then we know that this is ln x plus 1, 0, 2. Okay. And then thereafter is basically just a numerical computation. Just let me give that a try here. 2 over 3, so we have to substitute the 2 first into here. We will have a ln, let me see, that would be 16 over 3 minus of ln 10 over 3. Okay, that's my first part. And then the second one is basically just ln 3. Okay, so from here I can simplify further. I would have a ln, let me see here what we have. I will have 2825. Okay, so that's what I have, ln 3 there. Right. So if you want, you can just leave it as it is. If you have a calculator, by all means you can key this one into your calculator there, or you may want to write this in a different form. For instance, some of you may like this 1.6 plus ln 3. Now this will be the area underneath the curve, the blue region here. So this one will be, I will write this down as unit squared. Alright, so I hope that is of help to your integration technique. Right. But anyway, don't get too excited with the integration. We still have to finalize the total area bounded by the straight line, bounded by the curve, and the x-axis together with the vertical line x equal to 2. Okay, so let's do this. So the total area, I'll just write here, total area that we need to answer in this question will be given as, just label as AT here. It's basically A1 plus A2. So we have our A1 here. I'll just write down 0.72 plus whatever result that we are looking at here. Ln 1.6 plus ln 3 unit squared. Okay, there you go. That is the that's the integration technique that we use to evaluate the area under the curve and the straight line there. Alright, I hope that this has been useful to you. Alright, thank you very much for watching this video. Again, if you are interested with the upcoming videos, do subscribe and then press the notifications bell. Right. Thank you very much. See you again.